assuming you read the problem in the description, I'll just read it. I just did your filler, so an antiproton is identical to a proton except it has the opposite charge, E minus, or negative E. To study antiprotons, they must be confined with an ultra-high vacuum because they will annihilate, producing gamma rays. If they come into contact with the protons of ordinary matter, one way of confining antiprotons is to keep them in a magnetic field. Suppose that antiprotons are created with a speed of 2.0 times 10 to the fourth meters per second and then trapped in a 2.5 millitesla magnetic field. What is the minimum diameter? What minimum diameter must the vacuum chamber have to allow these antiprotons to circulate without touching the walls? So the answer is 17 centimeters. So I'll show you why. So imagine this post was brought to you by the Greek philosopher gang. But anyways, imagine an antiproton or a proton with apostrophe t at the end. Uh, and then you see there's a and it's moving to the right. It's moving to the right. Moving to the right. At 2 meters per second, and then the electric field is going toward into the screen, as you can see from this X, and the force is going up out of the way. But anyways, the yellow lines are the tube, are the walls of the tube that the protons are in, and then we are looking for the diameter of the particle accelerator, which is this blue line over here. So yeah. So first we have to understand that we need to use a, we need to use an equation for the magnetic force, and that's equal to the charge the charge times the velocity of the particle times the electric field that the particle is in. So as you can see, since it's inside a tube and it's basically going in a circular motion, it al- it the for the magnetic force is also equal to the centripetal force or something like that, where it's just the mass of the particle times the velocity of the particle time squared over the radius of the particle. So we have to set the magnetic force and the centripetal force equations equal to each other. So you get that mass times velocity squared over the radius is equal to the charge times the velocity times the magnetic field. One of the v's cancel out on the left side, and then so that the right side cancels the v, and you're just left with mv over r is equal to q times v. So as you can see, we are looking for the diameter of the tube, not the radius. So 2 times the radius is equal to the diameter. Diameter is twice the radius, so divide both sides by 2. The radius is equal to the diameter of the tube divided by 2. So we plug it in for r, and then now we get 2 times the mass times the velocity of the particle over the diameter of the particle is equal to the charge of the antiproton times the electric field. So now what we have to do is we have to switch the diameter and the charge and the electric field. So you're multiplying both sides by d, dividing both sides by qb, so that we can isolate d. And after you isolate d, we can now plug in the numbers. So I think I have carpal tunnel syndrome, so my arms hurting, so that's why this equation's large. So anyways, the mass the mass of the mass of the antiproton is the same as the proton, so it's 1.67 times 10 to the negative 27 kilograms, I think, right? And then it's moving at a speed of 2.0 times 10 to the fourth power meters per second. And then the charge of a proton, or in this case an antiproton, is still 1.6 times 10 to the negative 19. And then the electric field is given to us, which is 2.5 times 10 to the negative third teslas. And it's actually 2.5 milliteslas, but still SI units. You have to convert to the base unit. So yeah. Anyways, it equals to d, so you should get an answer of about 1.67 times 10 to the 10 to the negative 1 meters, or just 17 centimeters. So 17 pint centimeters. So that's your answer for this problem 29.63. But anyways, see you in the next video later. Oh, and sorry for wasting your time.